Section 1.5e, homeostasis, specifically that of serum glucose, otherwise known as blood sugar. So our set point for serum glucose is a range of 70 to 110 milligrams per deciliter. And again, a deciliter is a tenth of a liter. So think of a liter bottle of water, divide it by 10, that's what a deciliter is. So in 1 deciliter of blood, you should have between 70 and 110 milligrams of glucose in it. So when your blood sugar rises, like for example, if you're eating carbs, whether they're simple or complex carbs, your body's breaking them down, catabolizing those carbs into monomers, and those monomers will then, such as glucose, will then raise your blood sugar. When your blood sugar gets too high, specialized cells called chemoreceptors will pick up the information, send it through afferent sensory pathways to the control center. In this case, the control center is actually the pancreas, and is a portion of your pancreas that's responsible for integration. And the pancreas will then send efferent motor impulses to another portion of the pancreas and will stimulate the effector insulin. Insulin will be produced, and what insulin does is insulin travels throughout the bloodstream and basically grabs the extra glucose that's in your bloodstream and stores it in your cells for either immediate use or future use. Either way, you end up dropping your blood sugar back down to 70 to 110 milligrams per deciliter. Now, there are circumstances when you don't have enough glucose in your bloodstream. Like, for example, if you skip breakfast or you skip lunch and your blood sugar is running low. So what happens in that case is chemoreceptors pick up the information, send it through afferent sensory pathways to the control center. In this case, the control center again is the pancreas. And again, the pancreas decides, wow, blood sugar's a little low. We need to do something about that. So the pancreas will then send efferent motor impulses to the effector. In this case, it's another region of the pancreas to produce the hormone glucagon. And what glucagon does, glucagon travels throughout the bloodstream and goes towards your skeletal muscles and to your liver and says, knock, knock, we need sugar out here in the bloodstream, we're a little low. And your liver and skeletal muscles will then break down stored sugar in the form of glycogen, will break down the glycogen into glucose and release it into the bloodstream, thereby raising your blood sugar back up to the normal 70 to 110 milligrams per deciliter.